I got a background in organic chemistry, but I transformed into like an interdisciplinary direction called DNA-nanoteknologi, where you use DNA as a tool to assemble molecules, because you can program DNA to assemble, and you can put stuff on DNA and this way assemble it. And in 2007, I got a grant together with Kurt Vesterager and Jørgen Kemps, my colleague here at INAN for molecular biology, to study DNA-nanoteknologi, a new trend primarily in the US, where you use DNA to build material at the nanoscale by self-assembly. And I was so fascinated by that. And we had this grant for 10 years where we developed some completely new structures and methods. Together with my colleague Jørgen Kemps, we would like to go more in the biomolecular direction. So that traditionally molecules, drugs are small molecules, but in recent years it's more become big biological molecules that you use for treatments. And what we wanted was to take this a step further, where we wanted to put DNA on different components, biologics and also small molecules, and assemble those into what we call multifunctional drugs. And we applied for this with Novo Nordisk Foundation and got a big challenge grant to establish a new center together with Kemps and also Ken Howard here at INANO, and where we study these multifunctional drugs in relation to cancer and atherosclerosis, where such a complex can not only recognize a cancer, for example, but it can recognize different patterns of a cancer and then maybe kill it by having a toxin, or you can attract the immune system. We just published a paper in Angewandte Chemie where we take an antibody, and one of the modern trends in drugs is that you have both an antibody and a drug that is linked together. But normally you can only put one drug on an antibody, and then it's a really big molecule and a very small drug molecule. So to empower this, you would maybe like to put more drugs on the antibody, but this hampers the function of the antibody. We have developed a method where you take an antibody, put a DNA strand on it, and then a complex with DNA and many drugs. And you can put an exact number of drugs on this, and then we showed that this is much more effective to treat cancers in just in cell studies than if you have a single drug on the antibody. And this is one part of our current studies. There are many steps that have to be done before this can be applied medically. We have other studies where we have substituted the DNA with an analog so it's stable, because DNA itself is degraded if you put it into the body. But we've used an analog of DNA, and we are starting to do animal studies with these components together with our collaborators. So we are bringing it a step towards treatment. Our collaborator in Belgium in the center is doing clinical research, and our hope is to bring some of our diagnostic tools into humans before the end of this center that we have now. So certainly, I think within a limited timeline, some of what we do can be used for diagnostics, for treatment. Like drugs, it takes a long time, but this is definitely the way it's going. The reason that I find DNA nanotechnology so interesting is, first of all, this idea of molecular architecture, that you can design things that have a specific construction from molecules. They are so small that you can never grab a single molecule, but you can mix stuff and then it reacts or self-assembles. And DNA nanotechnology is particularly interesting because you can program DNA to assemble into very complex structures. Students that join my group typically do organic synthesis, but they also learn how to work with biomolecules. They learn a lot of biophysical techniques. They may even learn to work with cells, and a few also with animal experiments. So there you get, you say, a full package of different disciplines. And if you look at science today, also in companies like Novo Nordisk, it is also very interdisciplinary there. Of course, you need people who just synthesize molecules, but this is relatively few. You need people who also know the broader perspective of how you use these, and also macromolecules is playing a larger and larger role within the medical industry today. So I think this is why I think this is an important area.